announced that there has been a proposal of conducting conferences of this nature on foundations of quantum mechanics periodically. And we had a discussion, and it has been sort of tentatively decided that the next one will be in the December of 2026 in Kolkata in S.N. Bose Center for Basic Sciences. So I would request all of you to mark the calendar and spread the word around so that others, those who could not be present this time, they can plan from right now to be present at this conference. Many questions have come in this conference, and questions normally lead to new ways of thinking, new avenues of research. In the last session, as I said at the end of the last session, is that we are conducting this panel discussion in the sense of a conclusion of the conference. And when you write a concluding section of a paper, we sort of try to present the take-home message. So that is the purpose of this session. And we'd like to hear from all the speakers as well as the session chairs, their perspective. Effectively, the younger people should go back with a message, not just information. What is likely to become important in the future? What are the open problems? What are the prospects of solving different problems? All these issues. I'll request all the speakers to confine themselves to about 5 minutes to give that insight, and then we'll have some discussion. So let us start from this side. Professor, no, from you. We'll go this way. So you want Professor Jisno to start?
No, or from the more experienced who has been working for him.
Professor Dipankar Home to start with.
First of all, many thanks, Professor Banerjee. This conference, in a sense, is his brainchild. He really, so we should give a big hand. And the way he has been passionately involved in planning the conference and organizing to the minutest detail has amazed us all, and we are all very grateful to him for providing this opportunity and orchestrating such a wonderful batch of volunteers, and he pulled together the members of the organizing committee. In fact, we, the members of the organizing committee, who were local here, there to work hard. We did not have to work hard. All he did by himself, and with the support of his people here, and especially
Ritesh and Rangit.
Ritesh and Rangit. In fact, this combination has done all the hard work. So big thanks for Ritesh and Rangit. And we enjoyed all these days, and accommodation was beautiful, and everything went to the plan, and most of all the discussions and the talks were very stimulating, and of course much has been already said about the quality of discussions and the intensity of participation of students. In fact, I think this is what has encouraged this idea of having this conference at a regular basis, and it is of much pleasure and great hope that the next conference has been already announced with 2 years' time, so there will be enough time for preparation and organizing it properly and planning it properly. Regarding what is the future prospects and what are the things there are people here, and having worked in this area for 40 years, in fact, Calcutta has been historically in India, just to give the students a flavor how foundations of quantum mechanics in the historical perspective on studies on foundation a bit. The first work on Bell's theorem in India was done by S.M. Roy and Virendra Singh. That has not been talked about. So ideally, it would have been nice to have them here. But Professor that was in the year 1978. They wrote their papers on generalization of Bell inequalities, which was that time quite impactful. And it is a testimony to their interest in the foundational aspects that they began working in 1978. And India was largely dominated by particle physics and condensed matter. India is still dominated by, but at that time it was almost everywhere, and foundations was out of question, in fact. And I began my dissertation work inspired by my teacher in Calcutta, Professor Shamal Sengupta, and also I happened to visit them in 79, and then they had John Bell as a visitor because S.M. Roy, Virendra Singh and S.M. Roy was in CERN, and so he knew about Bell, and then he invited Bell to come to India. So that is not known, so Bell came to India at around 70, 80, gave a lectures. I have his slides, photocopies. So, and at that time, but anyway, I will not talk about this reminiscence. So that time 80, and that inspired us. And I was doing a summer project with Shashank Rai at that time as part of my post-graduation. And he then told me, I had been interested in Shamal Babu that you are teaching in Presidency College by him, and he at that time had the insight that this is going to be important, Bell's theorem. And I studied Bell's theorem with Shashank Rai, and then Shashank Rai was associated with John Bell. He was visiting CERN. And then I got inspired and did PhD at that time, which was a very risky decision. I won't advise anyone to do that. Even now, purely on foundations PhD. How, at that time, it was an era of romanticism in Calcutta, perhaps that influenced 70s, 80s. So 1980 is dissertation. But then hearing John Bell had visited TIFR, gave lectures, and I happened to come across many one. So I'm not going into all this, but saying that, so it began, but then in 90, the subject became gradually talkable, not respectable, even talkable, where I could give. And otherwise, when people ask, what are you doing PhD on at that time, they say, oh, this philosophy stuff, many of whom have now jumped into the bandwagon. So all these were there, just to tell you. So then, but of course, things started changing in late 80s, 90s, and then Guru Prasad Kaur, also with whom I had, there are many young persons gradually started, and he did his first PhD on quantum information, and I think he and Arun Poti were the first persons to do on quantum information PhD in mid-90s. So it is great that in Calcutta, we will be having these regular conferences, and this 100 years we had this. So, but I would say that now keeping it with the modern trend, contemporary trends, foundations, I think a lot of emphasis also on the synergy between theory and experiment. So of course, so one can go on working on the conceptual aspects, paradoxes, and clarify. But if you can, if we can build a synergy between theory and experiment, particularly in this part, then this foundational research will be more vibrant. And of course, there will be a close interplay with the information theoretic aspects. So the next conference may plan that way to emphasize on all the important proposals or even debatable proposals for experimental tests. I would not encourage debates about interpretations, particularly in the presence of the young students, because debates about interpretations of quantum mechanics, unless pitched at a proper level, right kind of speakers, and the audience should be also mature enough. But for this kind of conference, that would not be an ideal platform. We can have more debates about various kinds of proposals, because now I know, and President Nicholas knows, and many others, there are many exciting proposals coming for future experimental tests. And that is the next challenge, I think. How you can be clever enough, how you can be ingenious enough to translate these conceptual problems into testable ventures in keeping, so that you need exposure to what are the current available sophisticated experimental technologies. In that respect, this conference, we were only talking about interferometric photon tests. So this time, all these new levitated nano objects, all these new techniques are coming. Space-based quantum foundational experiments are coming from next year. So, and other tools are also being developed for experimental tools to which the students and young researchers should be exposed, so that even if they themselves do not work, so how to connect their ideas to that experiments. That attitude for that need to interact with the experimenters. So this kind of conference, if we can have sessions where we have sessions exclusively devoted to these proposals for future tests, or experimenters and theorists view who interact among themselves, who are open to this, to exchange ideas on this. So that is the future challenge. All these conceptual puzzles, like the tradition that John Bell began. So if we can focus on that. But apart from other aspects, that will be taken care of. Surely. Thank you.
Now, Professor Jisung.
Yeah, thank you. So take-home messages. I have some for myself and some maybe for you. So for myself, the main take-home message is the pleasure I had attending this conference, indeed in this quite unusual format, with a lot of discussions. And it was not obvious that this would be a success, and it has been a success thanks to the younger participants. Many questions. So here, yeah, thank you for having asked all these questions here during the public discussion sessions. But also, I know many of you came to me, asked a lot of questions, endless questions, and so on. Many also tried to attract me to your posters. And here I have to apologize to the many where I could not go to the posters because at the end of the day, I'm an old man and I was just so tired that I could not anymore. So yeah, I'm sorry that I couldn't go to every single poster. I also already started receiving emails, so you just have to know that I, in standard times, get already tens of emails per week requesting all kinds of things. It's just impossible to answer all that, and now after this conference I expect to get 100, and it's just impossible. So don't expect answers to every email. You have to, there's no logic. Sometimes I reply, most of the time I don't reply. So it is completely random. So don't be annoyed if I don't reply. It's just bad luck. Yeah, it's just, again, finite time. Yeah. So maybe what is now the take-home message for you? You know, we had quite a lot of good discussions, debates here, also friendly discussions. So that was again very pleasant. I think it's important to organize all these discussions in a friendly way. We can disagree, of course, that's okay, but there's no reason to fight for these kind of things. And it's clear that for some people, some of my dear colleagues, the goal is to understand quantum mechanics. Frankly, I'm not interested in that, personally. Of course, it's perfectly fine that some people want to understand quantum mechanics. But my goal is to understand nature. I want to understand this reality out there. You know, you can be a philosopher or some sort of physicist. You take textbooks and then you want to understand the textbook. You can also take an old book and you want to understand the old book. That is not my interest. Just to make it clear again. Also for some people, their motivation is to understand the mathematical or logical structure of some theory. And that's fine, that there are so people interested in that, that is fine. But this is not my way, it's not my research. You know, I'm pretty active or very active, but I'm not doing everything. There are things I'm just not doing because I don't find too interesting. So also, for instance, for me, I will never apply quantum mechanics to myself or to my friends. And you understand, so that there are some questions about friends which I don't find interesting. Again, I have no problem that other people find it interesting, but this is not something for me. So maybe here I should, again, as a take-home message, repeat something I said in my very first lecture, this famous lambda, that we have in Bell inequalities and so on. What is it? And I told you, don't think of lambda as an old-fashioned local hidden variable, but think of lambda as the state of the systems as described by any possible future theory. So for me, and I hope everyone here find it completely obvious, in 100 years, they will still be physicists. And these physicists, they will use some theory, maybe similar to quantum mechanics, maybe very different, but whatever theory these people will use in the future, they will make predictions. If not, it is not physics. They have to make predictions, at least statistical predictions. Now they have to predict the probability, let's say, of results A and B, given measurement settings X and Y, the usual thing, and so on. And these will depend on, I guess they will still have a concept of state, or maybe the concept will be a bit different, but of course it will depend on the situation, on the experimental situation they are considering. And this experimental situation is what we call lambda, that is my understanding of what lambda is. So thinking of that in that way, that is my interest for Bell inequality, is not to go backwards in time and reintroduce some classicality or things like that. I want to study physics, so the outside world, and already have an idea of how this future theory will look like. For instance, except if we get some signaling, maybe there will be these hidden influences or some kind of revolution like that. But if we stick to no signaling, we will still have not only violation of Bell inequality, but the randomness associated to it. So we will have a non-deterministic physical theories. So what should you be doing? Well, first important, you have to do what you like. It's very important that you should be working extremely hard. There is no reason not to work extremely hard. But for that, of course, you have to love what you are doing. So choose what you want. Do you want to study nature out there? Do you want to study the theory? Do you want to study the mathematics? Whatever. Make your choice. Do what you love to do. And then work very hard. But I would add a second point. When you work very hard on what you love to do, don't put your nose just like that. Be curious, be open, look a bit around, because if it's like that, and maybe the solution you are looking for is just next to you, but you will not see it because you are too much into it. So take a step back, and also take advantage of learning a bit things that are around. And here I come also back to what we just heard. There are, maybe you prefer to do the theory side, but there are experiments, so you can learn a bit about laser detectors, cryogenics, ion traps, or things like that go a bit around. And even if you're an experimentalist, learn a bit about the theoretical concept and also the experimental tools in the laboratory next door. So the main summary is do what you love and be curious.
So I would like to thank the organizers, all the speakers, and all the participants for making this such a great conference, which was, I think, academically very beneficial. So I wrote down a few of my thoughts. I'll read it out. The development of quantum theory is still not complete. Quantum theory is an approximation to a more general theory, even at currently accessible low energies. The more general theory should solve the following problems. How does one formulate quantum theory without making reference to classical time? Why does the wave function collapse during a quantum measurement? Why are the outcomes of a quantum measurement random, even though the Schrödinger equation is deterministic? Why do these random outcomes obey the Born probability rule? How do correlated quantum systems manage to influence each other outside the light cone? Does it mean that our understanding of space-time structure and of special relativity is incomplete? Why does relativity permit superquantum non-local correlations which exceed the Sirelson bound? The more general theory which answers these questions should also make testable experimental predictions. Now I have a small wish list. Young researchers should work towards finding this more general theory either as theorists or as experimentalists. Experimentalists should actively look for breakdown of quantum mechanics. Researchers working on quantum foundations, on quantum gravity, and on particle physics must talk to each other. Only when these fields interact will there be a progress in fundamental physics. For instance, there are more than 20 dimensionless fundamental constants in the standard model of particle physics whose numerical values are a mystery. This is a lot of experimental data already. To explain it, we need a better theory at currently accessible low energies, not more high energy experiments. The sought for more general theory is needed here as well. Somewhere in India, there should be a new center for foundational physics. The center should hire theorists and experimentalists working on quantum foundations, quantum gravity, and particle physics. This will be a unique center where India can become a world leader in examining foundations of physics. Thank you.
Thank you. Let me start by thanking the organizers once again for inviting an old man like me to this conference. It has been a tremendous, it's worked as a tremendous stimulus for me for two reasons. One is that this is the 100th year of the discovery of Bose-Einstein statistics, and I was lucky to have done my PhD with Bose, so it's nice to see the impact of his work, and that so many young people here who are keenly interested in foundational problems. When Professor Banerjee first sent me the invitation, I had a quick look at the possible speakers and I was absolutely stunned. And I immediately came to the conclusion they are not coming. Most of them will be on Zoom or so on. When I arrived here, I first met Professor Gisin and soon many other people, and I was absolutely stunned to see them in flesh and blood here. And that is a great, acknowledgement, I would say, of what is happening in India. India is changing. I can say this with confidence because I know the India in which I started my work, which was in 1963. And there is a tremendous change. And in those days, we didn't find so many young people attending seminars. They were all, more mature people. Now I find so many young people and asking so many interesting questions, even very technical questions. I'm stunned. And I want to congratulate the teachers and also the students for having attained this level. And I wish, let me say one more point. When I was doing my PhD with Bose, and I was working in particle physics, and he told me something. He said, unless you understand exactly how they measured what, you will not be able to do good theory. So this is what Dipankar was also saying. Try and relate your work to actual possible experiments, not not merely abstract high thinking. That is, do it at your leisure, by all means. But I think most of your work, because otherwise you won't get jobs. So be realistic, have your feet on the ground, work with experimentalists, and you will do better. And I hope this kind of conference will be repeated again. And next year it will be at my own institute, where I was one of the first to be appointed to that institute. I'm retired now. If I am still able to walk 2 years hence, I'll certainly like to come to that conference. Thank you.
Let me once again thanks Soumitra, Rangit, and Ritesh for their enormous effort to make it successful, along with the student from IJAR Kolkata who helped them. So this conference is a kind of little bit different, probably the young student who have already attended conference. In our other conferences, mainly we present our work and listen them, mainly that kind of things happen. But here, the most exciting part is the discussion. Now, this gives us, as a student of science, to learn one thing, and since I am working most of my life with the young student, so this, from a talk, you not only learn physics, you also, during this debate, you learn what should be the approach to science. I'm really astonished or thankful to all our speakers to entertain all these questions and patiently try to explain them. And Nicholas was telling he is not attend that much poster, but I can see always that at 7:30 also he is listening to the poster. And to the student who are learning all the subject from reading their paper, when somebody like this person come to my poster, that gives an enormous boost. That okay, I have to do more good work. And one of the message that I personally take from Nicholas Jesus' talk, that okay, foundation is of course we have to do, but do good science. Try to think how to apply it, how we can make useful things out of it. That is a good lesson, what is my lesson from this conference. And again, thank you all for attending it and actively participate in this conference.
Yeah, first thank the organizers for organizing such a nice conference and in a new mode. And all of the earlier speakers talks about this, that this is a new mode, but it was very successful. But Dipankar also mentioned some of the history, how foundation of quantum mechanics grew in India. But I would like to mention that Parthoda and Dipankar organized 2-3 big conferences where it was based on foundation of quantum mechanics. Maybe there are some quantum information, but mainly foundation of quantum mechanics. And it gave a boost to students all over India, but in the main, maybe students of Calcutta, they get more impetus from all these conferences. And I myself get the impetus to work in this field. And from this conference, as I agree with all the speakers that the participation of the students and speakers' response, all this was very, very nice. But with Manik, I will agree that we are human beings are thinking being. So sometimes it feels that you think, but important thing is, as I totally agree with Professor Jisa. Sometimes I also tell I am trying to understand quantum mechanics, but in a sense I also want to tell that I want to understand reality. And when you are going to understand reality, then we should take the approach of Professor Jisa, that you try to do something which either can be experimentally verified or can be applied. This is not just that you have to get a job. In this way, actually, you can learn about reality more. You can have a deep understanding of reality. So from this conference, I took this lesson from Professor Jisa that we should take this approach more consciously. Thanks.
Well, once again, obviously I will thank Soumitra Da, Ritesh Da, Rangit Da, and also other members of the organizing committee. And obviously, first thank goes to the panel of speakers we had. And they're wonderful, and all the talks have been very much learning for us. And all of you, particularly all the participants who very engaging way participated in the discussion. Well, I fully resonate with what other speakers said. I just add 3-4 points, possibly to give it a little bit a different dimension. My stand as far as interpretation goes, interpretation is actually part of science, because that's how we try to perceive nature. It's not mathematics through which we think, in a sense. We understand how things work. In a sense, I don't know exactly where from this quotation came. Possibly it's from Einstein. Once he was asked that, what do you mean by science? He said that you read any scientific book, maybe a rigorous textbook, you go through it, and then you forget. Anything that remains is actually science. That means the logical concatenation that you make. And here what we have learned is that this interpretation also should not be random. That means it also has to have some objective nature. In a sense, in other words, what Jisha said, should be testable. So this is absolutely important, and we must keep a note of that. So it's not a metaphysical discussion. Anybody who is serious about quantum mechanics or learning about nature in the microscopic scale must also care for how we try to interpret it. Because that generates new idea. And that's how possibly it will give us a clue in future to come up with some new theory, maybe new physics, new science. This is first. Second, quantum mechanics, because of this, let's say, I don't want to say this particular approach or that, but a general perception somehow created, possibly through our textbooks, media, and so, that it ignores objective reality. And from that footing, there are many forces you will find in the society, those pedal to propagate pseudoscience. You will see many of these pseudoscientific preachers use quantum mechanics every now and then to justify their unscientific claims or pseudoscientific claims. But here, one message we must possibly, at least I have got, is that serious quantum theorists do still resort to this conviction that reality is still there. Obviously, there are many more details or a newer understanding of reality is needed. So this is another part that is essential. Third, if you look at in today's time, the way we do research, we are essentially, because of corporatization of research or due to the pressure coming from the funding, particularly private funding, we are put into rat race of publishing research papers. And that is why whenever we go to a conference, we often see we try to publicize our work rather than try to understand what are the general problems of the field. We have been blinded so much with this belief that if I don't do this work, I will not survive. So sometimes we overlook the general problem and we are stuck to a particular problem, and that makes us too much compartmentalized. So here we try to flip, particularly when Soumitra Da proposed with this idea that we want to flip this. Here we will assemble not to publicize our own work, rather to collectively understand the problem in a better way and possibly collectively make an effort to solve them. I think this is where the essence of science. Science is a collective endeavor, and the present form of doing research essentially hamper the development of science. And I think to some extent, getting the responses that we have so far, that we are successful. And in that sense, we are really, really thankful and hope that this particular trend will continue and will be with more strength and power later on. Thank you very much.
Would anybody from the audience like to make any comment? Yeah.
Hello. Yeah, comment means actually I again say that I'm from a different field, but I have been interested in the foundational questions. And when I finally come here, I must confess one thing. I was confused earlier. I am much more confused now. So, yeah. But the question that comes to me at this point is, of course, as Professor Gisin and others said, that it is a kind of never-ending process. We go deeper and deeper, broader, and encompass a more and more regime of reality within our theory and understanding. But at every stage, we are stuck somewhere. For example, 120 years ago, we are stuck somewhere, and there are different proposals about atomic models are coming. And then finally, from both theory and experiment side, we have to converge. And then this quantum theory, and not only theory, but the quantum view of the world that came. And now, this is kind of a time that I personally felt from the discussion that we are some kind of this kind of stage where a deeper understanding of reality is required. But at this point, what appears challenging to me is the experimental side. That the proposals that has been made, or there are many different theories suggested, right? I mean, many of the speakers or other people whom I had been talking personally and from the discussion that came out, that there are different views towards reality, and we are exchanging, but we are also kind of closely attached to one view. There may be, there are different views. So as a, young student, I would say, who want to start something in this arena, so what should be the ideal approach I should take? One is my interest. But if I say it is already a mess, should I choose one of the mess or should I add to the mess? So what I am saying that what should be the approach with which I should go ahead. As a student, that is my first, curiosity. And the second thing is, what should I say? What is the standing today? Because there are many philosophical questions, many approach came which says that it should be understood at a more fundamental level where you should incorporate high energy physics, quantum gravity and all. And there are the other operational side. I don't know whether my language is correct, where I kind of try to find different no-go theorems and then see whether it is violated or not. And some postulates I accept, some others I reject. And so that gives me a better view. So my concern is, what is the, the approach is important. This came from you. So what is the best approach at this point to work on a theory or to build a new theory? These two things are, I just want to know.
Should this session also be like a question answer, or?
Can I say something?
Sure, sure, please,
okay?
Please.
Yeah, I would say nobody should answer this question. You should find your own path. You have heard everything. What is your inner conviction now? So if you don't mind, I'll give my example. It's not a great example, but what thought process I went through. I grew up studying normal quantum mechanics. I was 40 years old when I first understood that the Born probability rule cannot be derived from the Schrodinger equation. I was shocked, you see, because my teachers always told me mod psi square is probability. So mod psi square is probability. But how do you prove it? No, there's nothing to prove. Mod psi square is probability. But Schrodinger equation is deterministic. It cannot give you a derivation of probabilities. It will at the most tell you that mod psi square is conserved in time. It doesn't evolve. And then experiments tell us, as of now, that mod psi square is the probability. But the answer is still not known. If my teacher had told me in the class when I was a student like you that Born probability cannot be derived from quantum theory, we would have started thinking then. So this whole thing is a series of accidents. So many of us very late in life realize that there is something fishy about quantum theory and we need to do better. So we are trying to tell you all, don't wait till you become old. It's an important problem. Please start now. Do other things which will get you a job, but some 50% or whatever of the time devote to this. But ask yourself what is important. Don't ask anyone for an approach. It will likely be wrong, and you will be cursing us for misguiding you. So you have to ask yourself. But that is also a happy process, no? Let it go this way, that way, wrong way. I think all of us have come from the wrong way.
Any other comment from the audience? Yes, there. Can somebody take the microphone to her?
Good afternoon, everyone. I am Shoili. I'm from Aizer Mohali. And I work in an experimental quantum computing lab. So I do not explore the foundational aspects in that sense, nor does my group. And when I told people around me in my institute that I'm going for this conference, everyone thought that I just want to go home and get my travel reimbursed from the institute. That is why I'm going. People also kept on telling me, why are you going for the conference? You will get bored. No one will listen to you. No one would pay attention. And maybe they are also not wrong because of the preconceived notion they have had. Even I myself had met people who explored the subject in a more theoretical approach and who do not do experiments. They take some sense of pride in saying that, oh, I'm a theorist. I don't understand experiments. And I don't even care what you people do. I'm a theorist. I don't understand anything. And after I came here and I saw people giving an equal importance to experimentalists and how experiments are actually done. And there were also eminent personals who work in the experiment fields. For example, Professor Ashok Ajay, he spoke about NV centers, and there was also Urvashi ma'am and everyone. Like, I was actually very demotivated when people told me, like, no one in the theoretical field cares about the experiment. And I was so demotivated that I even ended up asking Manobda, if no one accepts my abstract in the conference, can I still attend? So this was what I initially thought. But after coming here and listening to the speakers, and also after having this experience of people coming and asking about how we actually do experiments in our lab, and people doing theory, wanting to collaborate and like realize their theory experimentally. So I have an immense sense of belonging that we also as experimentalists count somewhere in the greater picture. And I'm actually taking home this immense sense of belonging that, like, I too belong somewhere here and I too also count. So thank you, all of you.
That's a beautiful remark you made. Please remember this. No theory of physics was ever accepted unless first confirmed by experiment. So you come first, we come second.
Any other comment from the audience? Yeah, there.
Hello everyone. I'm Harsh and I'm from IISER Kolkata. I recently completed my thesis under Professor Soumitra Banerjee, and I would just like to share like how my views kind of evolved along this 2 to 3 year journey. Like prior to my thesis work, I was interested mostly towards this philosophical kind of questions, borderline philosophical questions. Like in the textbooks, we were introduced to quantum theory, and I first searched it out like in multiple books for the postulates and everything. And in all the places, they mentioned something like an observer, something like in measuring the apparatus, measurement, collapse, and so on and so forth. And I was very curious, like, what does this mean? Like, this is not encompassed within that. And that was my main source of like curiosity. Then I got into this Wigner's and Bell locality and all of that stuff. I read so on and so forth. And then I approached him. So during my thesis work, I particularly remember this, that he constantly kept pushing me to, whilst like working on new theoretical ideas, you should search for some implementable, implementable scenario where you can test that model or that theoretical framework out. And that was kind of like a big learning for me during my whole thesis work. And along with this, actually, this marked like how my view of science also changed. At first, I was interested in just understanding the theories better, like understanding classical mechanics better, the assumptions that go into it, then understanding quantum better and the assumptions involved in writing that theory. But later on, I realized that physics is not really about the theory, nor is probably science about the theory. It's actually about nature and like our quest to try and understand nature better. So that's why any theory or philosophy interpretation is kind of hollow. Well, hollow is not right. A fantasy or story if it's not supplemented by experiments. So that is something that and actually Professor Jizen, I like the combination that each theoretical talk was kind of complemented with an experimental one as well. So thank you, that was my learning.
Any other comment from the audience? Okay, if
Professor
not,
Banerjee, could I want to read out one favorite quote of Einstein. Would that be a good way to?
Sure.
Yeah, so this is a remark that Einstein made about quantum mechanics in 1936. It is published in the Journal of the Franklin Institute. So I'm not making it up, you can look it up. So this is what he's saying. There is no doubt that quantum mechanics has seized hold of a beautiful element of truth, and that it will be a touchstone for a future theoretical basis, in that it must be deducible as a limiting case from the basis, just as electrostatics is deducible from the Maxwell equations of the electromagnetic field, or as thermodynamics is deducible from statistical mechanics. However, I do not believe that quantum mechanics will be the starting point in the search for this basis, just as one cannot arrive at the foundations of mechanics from thermodynamics or statistical mechanics.
So we are sort of coming to a close. If anyone from the panel would like to make the final comment, welcome. Otherwise, we'll call it a day. Sure.
The comment is not regarding any scientific thing. It's just my gratitude towards all the physics faculty of IISER Kolkata who made this thing happen. My professor Ritesh sir, Soumitra sir, and also Rangit sir. You all did a really great job, and it was a great time talking and hearing these great scientists and great minds. So it was a really very nice opportunity for me to learn about their approach towards science. And I just had a small sadness is that when you next time organize such a conference, please make sure that our guests get to eat aloo posto and shukta, because those two delicacies I had promised Dr. Lee Rosima that I would feed him aloo posto, but I didn't get the chance to feed him aloo posto. So please, next time, please make sure that Dr. Jisa and any other foreign professor gets to eat aloo posto. Oh, thanks for adding the payash. But aloo posto, sir, can't be replaced. So, thanks.
Aloo posto. Posto is
poppy seed.
No.
No, it's poppy seed.
Poppy seeds. Yeah.
And aloo is potato.
Any further question apart from aloo posto? Okay. Would anybody from the panel? No. Okay. So let us bring this conference to a close. My request to the panelists or the speakers: you have got a cup. Please keep the cup on your table in the office so that others who come to your office get to know that this conference happened. And you see, we cite papers published here, there. Can we not cite conferences? This question was raised in this conference. So, yeah, it's possible. What I'm saying is, essentially, we are going back with a message. We have learned talks. We have learned what is already known. It's important to know what we don't know. If we have learned that, what we don't know, rather than what we know, then that is a bigger achievement, bigger gain, than only knowing what is already known, right? And I expect the students who are here, or young researchers, to take up and take along these questions. And my vision is that in the years to come, you will be in the forefront of the field. If this conference has been able to do something to that effect, I'll really be proud. Thank you.